Solving quadratic equations and inequalities. Given a quadratic, f of x equals ax squared plus bx plus c, to solve a quadratic equation, f of x equals 0, first try to factor and solve. If not factorable, use the quadratic equation, or complete the square and use the square root property. The real number solutions are x-intercepts of f of x. To solve a quadratic inequality, f of x is less than or equal to, less than, greater than, or greater than or equal to 0, we will need to find the real number solutions by solving f of x equals 0 and perform a sign chart analysis or sketch f of x with x-intercepts and determine on what x-intervals f of x is above or below the x-axis. If f of x equals 0 has no real solutions, we can still do a sign analysis of f of x. In this example, we want to solve the equation x squared minus 4x minus 12 equals 0. Well, we have the quadratic on one side and equals 0 on the other side, so we should first try to factor. And this is fairly straightforward to factor because the leading coefficient is 1. So we can go ahead and factor this to be x minus 6, x plus 2, is equal to 0. So if we check, outer is plus 2x and inner is minus 6x, so that will add to be negative 4x. And we are solving, so we set each factor equal to 0. So we'd get x equals positive 6 and x equals negative 2. So our two solutions are negative 2 and positive 6. Alright, so now we move on to solving the inequality. So the inequality x squared minus 4x minus 12 is greater than or equal to 0. We want to solve this first by graphing. Well, the first thing we do need to do is solve the equation for the real zeros, for the real number solutions, because those are going to be the x-intercepts. So here, the first step would be to solve the equation x squared minus 4x minus 12 equals 0, of which we know negative 2 and 6 were the solutions. But what that means, what that implies, is that negative 2 comma 0 and 6 comma 0 are x-intercepts. So if we want to solve this by graphing, well, we have x-intercepts. We can go ahead and graph them. So we have negative 2, 0, and 6, 0. And this is a quadratic, which will graph a parabola that opens up because the leading coefficient is 1. Now the nice thing is that we only need a really rough sketch of the graph. So when we say by graphing, all we really need is the x-intercepts and the general shape. So whether it opens up or down. So we have the x-intercepts. We know that it opens upward. So I'm going to go ahead and just sketch this upward facing parabola here. So we want to go ahead and interpret this greater than or equal to 0 on the graph. So that means I want to know when I'm above or on the x-axis, right? 0 is the x-axis. So if I want to figure out where am I above or on the x-axis, I'm going to go ahead and shade those pieces and then describe them using intervals. So these are x-intervals where we're describing where the graph is above or on the x-axis. So that's going to happen on the interval negative infinity to negative 2, closed bracket, because that's where I'm on the x-axis, and 6 with a closed bracket to positive infinity. So all of the numbers in these two intervals, when substituted into x, on the left side into this quadratic, that's going to give me a number either greater than or equal to 0. In the third part of this example, we want to solve the same inequality x squared minus 4x minus 12 is greater than or equal to 0 analytically. And this means by creating a sign chart. So we're going to pretend we haven't even done this problem at all. So what we would do is we would start out by setting the quadratic equal to 0. So even though it's an inequality, we do have to try to set it equal to 0 to find its real solutions, if it has any. So here we did do this work before, so we said x minus 6 times x plus 2. So we got out negative 2 and positive 6 as solutions. All right, so now we're going to go ahead and create a sign chart. Now a sign chart is constructed by creating a number line. And the number line is going to extend over the domain of the function. So the domain of the function, the domain of any quadratic, is all real numbers. So negative infinity to infinity. And we're going to put these real number solutions onto the number line. So negative 2 has to go first, and then 6 next. So we always go from least to greatest. And I like to go ahead and above each one of those put a little z to remind myself those were zeros of the function. Now what we need to do is figure out over each interval, so from negative infinity to negative 2, and from negative 2 to 6, and from 6 to infinity, what is happening to the function? Is the function positive or negative over each of those intervals? So we are interested in the sign of the function. Let's call it f of x. So let's go ahead and say this function here was f of x. So I'm interested in the sign of f of x. And in order to determine that, the easiest thing to do is to consider f of x as its factored version. So I want the sign of quantity x minus 6, quantity x, plus 2. So in order to determine the sign, we're going to pick a test point value in each interval. So within each interval, I'm going to go ahead and pick a test point. So between negative infinity and negative 2, I can pick any number, but I'm going to go ahead and pick like the nicest integer that's to the left of negative 2. So I'm going to go ahead and pick negative 3. So up here, these are going to be my test point values, my testing values. Between negative 2 and 6, well, the easiest value to choose would be 0. 0 is definitely between negative and positive. And in between 6 and infinity, I'm going to go ahead and choose 7. So these test points, what we do is we substitute them into the function. I want to know the sign of the function. Is the function positive or negative? So here, negative 3, if we plugged it into the original function, I'd actually have to do a lot of work. Well, I'd have to do negative 3 squared minus 4x minus 12 and think about if that overall number is positive or negative. The benefit of using the factored version is I can go ahead and think about each factor's sign separately. So if I plug in negative 3 minus 6 is going to give me a negative value. Negative 3 minus 6 is negative 9. But I don't even have to care that it's negative 9. All I'm going to do is put that it's a negative. So this first factor is negative, and then negative 3 substitute into x plus 2 is going to be a negative 1. So I have a negative times a negative. Well, a negative times a negative is a positive. So this first interval from negative infinity to negative 2 is a positive interval, and we wanted positive intervals, so greater than or equal to 0. So part of my answer, I'm going to start writing it already, part of my answer will include this interval from negative infinity to negative 2. So negative infinity to negative 2. Now the reason why I put a z above negative 2 is to remind myself that's where I was equal to 0. And I want to know when am I greater than or equal to 0. So I am going to include that negative 2 value. Then we move on and check the next test point. So 0 minus 6, that's going to be negative. But 0 into x plus 2 is going to be positive. We know a negative times a positive is overall a negative. So I don't want that middle interval. I don't want to include all the numbers between negative 2 and 6. And then finally, I go ahead and test 7 into each factor. 7 minus 6 is positive, and 7 plus 2 is positive. So I have a positive times a positive. Overall, I have positive. And again, I wanted to know when am I greater than or equal to 0. So I want positive intervals. So I do want to include the interval from 6 to infinity. 6 was where I was equal to 0, so I want to go ahead and include 6 and go all the way to infinity. And we did do this graphically, so we know that this confirms the same answer. On this example, we're going to go ahead and solve the equation x squared plus 1 equals 0. Well, x squared plus 1 is the sum of squares, which we know doesn't factor. But in order to solve this equation, we can use the quadratic formula, but because there's no middle term x here, like a bx term, we can also just go ahead and subtract the 1 to the other side, so we get x squared equals negative 1. And when I take the square root of both sides, I'll get plus or minus the square root of negative 1, which should give us some sort of red flags because a negative underneath the square root is an imaginary number. So what we have is plus or minus I. The imaginary number I is the square root of negative 1. So this does have solutions. This has the two solutions, negative I and positive I. However, those are not real numbers. So these are solutions, but they are imaginary solutions or complex number solutions. So now when we go to part B and we think about the inequality, solve the inequality x squared plus 1 is greater than or equal to 0. Well, here we have two choices. We can solve this graphically, or we can solve this analytically, so using a sign chart. So if we think about this graphically, we know that there's no x-intercepts because there's no real number solutions to this quadratic equation. But that doesn't stop us from graphing. In fact, graphing is pretty straightforward. So the graph of x squared plus 1 is just going to be the graph of x squared shifted up 1 unit. So everything's going to shift up 1 unit. I'm just going to do a rough sketch here. So if I were solving this graphically, when is x squared plus 1 above or on the x-axis? Well, it's always above the x-axis. So the solution is all real numbers. I'm solving for what x values can I plug in to give me positive outputs. Well, I can plug in absolutely any x value. So my answer is negative infinity to infinity. So all real numbers. Now, if I didn't draw the graph, I could still approach this analytically and do a sign chart, but my sign chart would be really boring. I would have negative infinity and infinity, the domain of the function, but I wouldn't have any zeros on here, right? I wouldn't have any x-intercepts. There's no real zeros. So I could pick a test point, any test point I want, like 0 is probably the nicest test point, and I would substitute that test point in to find the sign of f of x, or the sign of, let's just say, x squared plus 1, the function. Now if I plug in 0, 0 squared plus 1, that's going to give me 1. That's going to give me positive. So on the entire number line, my outputs are positive. So again, just confirming, the answer is negative infinity to infinity. Now before we move on, just real quick, I actually would say that none of this work was necessary if I really understand the concept here of this inequality. We're asking ourselves, what x values can I plug in so that when I square them and add 1, that's going to give me a number that's greater than or equal to 0, or positive. Well, anytime you square something, you're going to get out a positive answer, and then you're just going to add 1 to it, so it's going to stay positive. So that's why the solution is all real numbers. In this example, we want to solve the inequality 2x squared is less than x plus 10, both analytically and by graphing. So this is slightly different because I don't have a quadratic less than 0, but I'm going to have to create that situation. I do want that to move forward, and I'm going to accomplish it by subtracting the x and subtracting the 10. So we actually want to solve the inequality 2x squared minus x minus 10 is less than 0. So to start this problem, we're going to do it analytically. We do need to solve the equation first. So we need to know, when is 2x squared minus x minus 10 equal to 0? We want to try to go ahead and solve by factoring. So we're going to have a 2x and x. That's the only way we can go ahead and get 2x squared. And then to get negative 10, well, we can use either 10 and 1 or 5 and 2. The values that I'm going to go ahead and use here are 5 and 2. If I go ahead and put a 5 right here, that's going to make the inner 5x. And if I put a 2 here, that's going to make the outer 4x. And so I just need the signs to work out to get a negative 1 in the middle. So I'm going to need the 5x to be negative and the 4x to be positive. And then last is going to give us negative 10. So this is my factorization. It's going to leave us with the real zeros. X equals 5 over 2. Because I'm going to set this equal to 0, I would add the 5 and divide by 2. And then here I'm going to get x equals negative 2. So these are my real number solutions. So, I mean, we could take the time to put them in squiggly braces, but this was honestly just scratch work. Because we're going to now go ahead and put them on my number line. So my domain of any quadratic, negative infinity to infinity, I'm going to put negative 2, positive 5 over 2, remind myself that these were zeros. And then what we're interested in is figuring out, well, over each interval, what is happening. So we have to pick a test point in each interval to determine the sign of the function. So my test point here, we'll go ahead and pick negative 3. So TP is going to stand for a test point. Between negative 2 and 5 over 2, we'll pick 0. And 5 over 2, well, that's 2.5. So a number bigger than 2.5, that's pretty nice to work with, is just 3. And we're interested in the sign of the function. Now, the function is 2x squared minus x minus 10. But it's always going to be easier to use the factored version in our sign chart analysis. So we want the sign of the factored version, 2x minus 5, times x plus 2. So substituting in negative 3 into each factor, we would get, well, negative 3 times 2 is negative 6 minus 5. So that's going to give me a negative 11 or a negative. Negative 3 plus 2, well, that's negative 1, so another negative. A negative times a negative is a positive. Now, do I want positive numbers? Let's see. I wanted to know where is the function, the original function, the factored version, right? Doesn't matter. Where's the function less than 0? That means negative. I want negative intervals, right? So this less than over here means that I want negative intervals. So I do not want to include this first interval. So then we go ahead and move on to substituting in 0. 2 times 0 minus 5, that's going to give me a negative. 0 plus 2 is going to give me a positive. So a negative times a positive is a negative. I do want to include this interval. So this interval goes from negative 2 to 5 over 2. And we do not want to include those numbers because I want to know where am I strictly negative, not where am I negative or equal to 0. So in my answer, I want to use open parentheses, negative 2 to 5 over 2, open parentheses. So any number in this interval will work in this inequality. 0 was just a test point that we chose, and so any value will follow the same behavior as that test point. And then finally, when I plug in 3, 2 times 3 is 6, 6 minus 5 is positive 1, 3 plus 2 is another positive, so this interval is positive. We do not want to include positive intervals, we want negative ones, so here is my answer. Now let's go ahead and confirm this by graphing. So to have solved this by graphing, we still would have had to set the equation equal to 0 and get 5 over 2 and negative 2, but we would have interpreted them. We would have thought about, well, these are x-intercepts, right? So 5 over 2 comma 0 and negative 2 comma 0 are my x-intercepts. So we'll go ahead and plot negative 2, and then 5 over 2 is 2.5. These tick marks are by 2s, so you have to be careful. And then this parabola, we just need the general shape. So my parabola is going to open upward here because the leading coefficient is positive 2. And so we're going to go ahead and sketch this upward facing parabola. That wasn't quite right, so I'm going to try one more time. Probably a little something like this. I tried to actually make it kind of accurate. Let me move it over. I do know the y-intercept is -10, although I don't need it, right? So that's additional information. If I were being asked to graph a comprehensive graph of a quadratic, I do want all the intercepts, but I'm using this graph to determine where am I below the x-axis. So we could think about this as less than symbol as negative when I do a sign chart, but what I really want on a graph is to think about where am I below the x-axis. Well, I'm below the x-axis between -2 and 2.5. That's how we got this x-intercept. It was 2.5. Now, before we move on from this topic completely, I want to go ahead and go over a common mistake that students make so that you don't make the same one yourself. In solving this inequality, 2x squared is less than x plus 10, sometimes students will go ahead and start out correctly, subtracting the x and the 10 to the other side, and then factoring. So quantity 2x minus 5 and then times quantity x plus 2 is less than 0. But at this point, they mistakenly treat it like a quadratic equation. And in a quadratic equation, I can take each factor and set it equal to 0 when this is equality. And that's because of the zero product property. In order to multiply and end up with an answer of 0, one or the other of these has to be 0. But in this case, I cannot apply that same way of thinking. So what sometimes students will do is they'll go, all right, well, I'm going to take 2x minus 5 and set it less than 0, and x plus 2 and set it less than 0, because they're thinking about solving an equation. But here, that logic doesn't work out, because in order to multiply two things and get a quantity less than 0, it could be that the first quantity is negative and the second quantity is positive. That's one way to get a negative answer, or vice versa. So we can't use that same logic here. It doesn't work out. So I cannot solve this problem by setting each factor less than 0. So that only works if I have a quadratic equation. Once I have any inequality, this way of thinking no longer applies.